All right, so everybody knows we're recording now. All right, let's go back to yesterday and make sure everything is okay. Did anybody have any particular questions with section 1.1? Because today we have a lot. We have 1.2 and 1.3, because I really believe it's kind of easy. All right. But there are some things here that if anybody'd like me to discuss, we can discuss those. Yes, ma'am.
For questions like in 34.
34.
Does the point SR and
You are amazing. That's a great question. So someone tell me, how many planes do they see? Oh,
I see 6.
3.
3. What about 7 and 6? Which one is the answer?
7. 6.
Elise, why is it 6?
Because if you like count the one that's on, and then you count like where they meet up, and then you just like count on the side.
Yeah, but it looks like there's 7 different planes. But the answer is 6. I'm totally agreeing with you. Why do some people think it's 7? Tell me, Abigail.
SRM is already on plane A.
Yes, brilliant. Exactly, guys. All right, some people think it's 7 because they think plane A is different than MSR. But are they different? No, it's the same plane. Does everybody agree with that? All right, so it's kind of a tricky question. All right, so if you put 7, I understand that. There are definitely 6. All right, that was a great question. I'm glad you asked. Somebody else? Everybody knows now what collinear and coplanar means, right? Nothing else on here before we go. It's kind of easy. Nothing? All right, kiddos, let's go. Put in section 1.2 and 1.3. And tomorrow I'm going to do 1.4 and 1.5, and then we'll start using our book on Monday. All right. So we'll have assignments out of the book. All right, but I wasn't sure how good the book is because sometimes we have trouble. Everyone was able to get into their book now, right? Because as soon as you guys left, look and see now. See if it comes up. I need to know if you can't. Maren, were you able to get into your electronic book?
What app is it?
It's the McGraw-Hill. It's the
Okay.
Connect. So look and make sure. So I need to take Kate. You can't?
It says install error.
Yeah, I'm downloading.
Yeah, everybody try to do that. Kate Mitchell, you said yours not doing it at all. All right, so don't worry about it. I'm going to take care of it. That's why I did this. Maren, you let me know if it's downloading or not. Is anybody else having trouble? Oh, I didn't give you the password, did I, Maren?
I don't think so.
All right, so let's just wait. I'll email that, or not email, but put it in Classroom. All right,
Okay.
I'll put your code in. And then you can just do it later. All right, because I want to go ahead and get started with today. All right. So anybody else can't get into the book? Everybody else is good besides Kate Mitchell. All right, I'll figure out why. I have no idea why. All right, so let's go ahead now and just get started. All right. Now, today, I believe it's a simple concept. So if everybody takes a look at number 1, find the measurement of each segment. They want to find the measure of NQ. And what is the measure of NQ? Yeah, I told you guys. Geometry is very simple. 2 1/4 inches. All right. Now, believe it or not, this is something that I never really understood. This is called the segment addition postulate. So now somebody tell me why it's a postulate again.
What's a postulate?
That's what I told you yesterday. That's why I'm seeing if you listened. What's a postulate? And what's a theorem? Those are the two different things. Yes, exactly right. So if you forgot what a postulate is, write that down. Postulate is something you have to accept as true. All right. Now, again, didn't understand why segment addition, why it's called a postulate and not a theorem. So they're telling me that there's no way for me to prove that QP plus PN is equal to QN. There's no way to prove that. You have to accept that as true based off observation. All right. To me, that was a little strange. All right. So the segment addition postulate, another way of saying is just the two what? The two parts always do what? Add up to the whole. That's what they're trying to tell you. The parts equal the whole. All right. That's a segment addition postulate. All right. Super simple. So obviously AC would be what? 10.1 centimeters. And then GH would be what? 5.3 millimeters. Anybody have any issues with that? All right. Now, if we look at 4, 5, 6, and 7, find the value of X and YZ. If Y is between X and Z. If Y is between X and Z, somebody tell me what is true. If Y is between X and Z, tell me, Harrison.
XY plus YZ is equal to XZ.
You are amazing. That's really good. All right, that's the segment addition postulate. XY plus YZ. Uh-oh, I wrote it wrong, didn't I? I sure did. XY. So if, no, I didn't. Y is between. No, that's correct. I'm sorry. XY plus YZ equals XZ. That's exactly correct. All right, so now with that information, if you want, sometimes it's easier to just draw the segment. And if you put X, Y, Z, sometimes it's easier to see. So if we're writing the equation, we would just say what? For number 4, guys. Go ahead, Harrison. Want to tell them?
XY is 5X. And you just make one.
So what are we going to say? 5X.
Oh, 6X is equal to 25.
So XY is 5X. YZ is X. So let's just go ahead and write the equation, even though I know what you mean. So it would just be what? Someone tell me. 5X what? Say it again. Yeah, plus X equals. Oh, wow, I made a mistake. Look at this. I was assuming they were going to tell us what? To use the segment addition postulate. But they're not. It's just XY equals 5X and XY equals 25. I don't really like that question. So what's X, guys? Yeah, that was my mistake. X equals 5. So if X equals 5, and they also want to know what is what? YZ. So YZ is also what? 5. All right, that was kind of silly. All right, so now over here, they have XY is what? 12. What's YZ? Plus 2X equals 28. All right, now's the time where we just got to speak up since I kind of messed up the first question because I just thought it was going to be like number 5. Is everybody okay with that now? All right, now, of course, we just work our mental math magic here. And again, everybody's smart enough to just tell me X is equal to what? 8. All right. Remember, I'm just expecting you to just solve that in your head. X equals 8. Then it says we want to find what? YZ. So then you just say off to the side, YZ equals 16. All right, so let's do number 6 real quick. So somebody tell me the equation here.
4x plus 3x equals 42.
4x plus 3x equals 42. Beautiful. So then we just say x equals 6, and then yz equals 18. All right, if you're super fast, go ahead and do number 7. All right, I'm not going to do that. All right.
Mr. Shroud.
Yes, ma'am.
I'm a little confused on like the form or like the xy plus yz equals x2 or xz. I don't know what that means.
Tell me which one you're talking about, 4, 5, or 6.
Like 4.
All right, so 4, I kind of messed up because I thought they were going to be talking about the segment addition postulates, and they weren't. So look right here. XY is 5x, right?
Yeah.
Well, they define XY as 25. Bless you. You see what I'm saying?
Oh yeah.
So those two things are just equal. So 5x equals 25.
Uh-huh.
It's not like 5 and 6. Honestly, I think there's a typo. I think this should have been YZ or something, but I could be wrong.
Okay.
They might be just trying to see if you're paying attention. Does that make sense?
Yeah. Thank you.
All right. So just for me, guys, I'm not going to say anything, but number 7, who did it? X equals what? And then we want to find YZ equals what? All right. I'm happy with that. All right. Totally good. All right, Maren, you still good now?
Yeah, thank you.
All right, you're welcome. All right, let's take a look at number 8, 9, and 10. Determine whether each pair of segments is congruent. Okay, so somebody's got to tell me what congruent means. Now, congruent definitely can be equal. And actually, we're going to have something later that's called definition of congruence. All right, now, again, there's a difference between congruent and equal. All right, so again, I'm going to try to tell you what that is. All right, now, for me personally, if you say something is equal and you meant to say it's congruent, do I really care? I don't really care. But when you get to higher level math, if you would tell your college geometry teacher something is congruent when you meant to say it was equal, he'll probably mark it all wrong. All right, there's a big difference between congruence and equal. All right, equal is when you're comparing what? Values. All right, for example, when you say x equals 10, x has a numerical value, correct? All right, when things are congruent, you are talking about sides of a triangle are congruent. All right, the measures of the sides are what? Equal. Does everybody understand the difference? So if I'm saying something has a length, you would say it's what? Equal. If you're comparing two things that are exactly the same, they are what? They are congruent. All right, because you're not talking about the measure. All right. So is there a small technicality there? Yes. Do I care? No. All right. The congruent symbol is an equal sign with a little squiggly on top of it. All right. So if you say AB is congruent to AC, you're talking about they're exactly the same. All right. Now, if they are exactly the same, that means that their measures are what? Exactly the same also. That's why I don't really care. Does everybody understand that? All right. So here is the congruent symbol. All right. You say things are congruent if you're not talking about their measures. So if I'm looking at this figure, is BE congruent to CD? Yes. All right. They are congruent. All right. So you would write BE is congruent to CD. Now notice this also. And again, these technicalities, I don't mark you wrong, all right? But I just want to show you, technically, when you're talking about congruence, you're naming the side, all right? If the symbol is not there, you're referring to a what? A measure. Does that make sense? But once again, if you write BE equals 3, I'll know exactly what you mean. All right, hopefully that makes sense. All right, so number 9, is MP congruent to NP? No. And then over on number 10, is WX congruent to WZ? Right, what does the tick marks mean? They're equal, right, or they're congruent. So they should say XW is congruent to what? YZ, or YX is congruent to ZW. Everybody okay with that? Another little definition here. All right, so now I'm going to give you a formal definition of distance between 2 points on a number line. All right, the distance is always the absolute value of A minus B. Can distance be negative? That's why we use a what? That's why I use absolute value. All right, is everybody okay with that? All right. So now, all right, you can find LN by just saying I started at 3 and I ended at what? So I know it's what? 6. That's how the average kid would do that, right? But we can say it's just the absolute value of what? 3 minus 9, or we can say the absolute value of what? 9 minus 3. Everybody good with that? Do I care? I don't care how you do it. Just you have to know when someone's talking about distance, distance cannot be negative. All right, distance cannot be negative. All right, so JL from -5 to 3 is what? 8. Is everybody happy with that? Now, again, just to make sure I'm covering all the bases, -5 minus 3 or 3 minus -5. Is everybody seeing how that works? It doesn't matter how you subtract them. All right, so the distance between 2 points on a number line is the absolute value of A minus B. All right, now from last year, does anybody remember the distance formula? Distance between 2 points on a plane. Yes, it is.
Parentheses, X.
Yep. Yep. Yep.
And then plus Y2 minus Y1.
You are amazing. That's exactly correct. So everybody's got to make sure you know the distance formula. The distance formula is on every standardized test. All right. And I told you last year, it is derived from A squared plus B squared equals C squared. All right. It's derived from the Pythagorean theorem. All right. And we'll get into detail on that as well. All right. I don't feel like I need to do both of these problems. Hopefully, there'll be time for us to review or work on our square roots here, but we'll find out. All right. So now, because we are smart, guys, I'm not going to write all the work out. We're just going to say square root. So if I do -3, what? Plus 1, right? What's -3 plus 1? Squared. 4. Plus, what's 8 minus 4? Squared.
16.
Does everybody agree with that? Now, remember, you're not taking my word for it. You got to do it in your head too, because if you come up with something different, just tell me. Does it matter if I go -3 minus 1 or -1 minus -3? Makes no difference, right? So what's the distance? The square root of what? All right, now who's going to impress me? How does square root of 20?
2 radical 5.
Yay, good job. 2 radical 5, guys. Anybody have any issues with that? You have to know radicals, right? You have to know radicals. And again, I'm always telling you guys, you're trying to get into high school. So you have to remember your algebra, all right, as well as remember the geometry, all right, which makes it a little bit harder. So that's why we're going to continuously review. Anybody have any issues with 13? All right, let's check out 14 now. So you guys see what I mean? Distance equals square roots. So help me, what is that? 6 squared,
36.
good.
-4.
Squared, good job. Whoever said that.
Whoa,
Distance equals square root of
52.
52. Now, obviously, there's a what in there? Common what? Now, how did I know there's a common 4? Come on, guys, I'm trying to make you smarter, so look up. How did I automatically know there's a common 4?
36 and 16.
Yeah, 36 and 16 have a common 4. So everybody agree with that? So that's how I knew it was 4 times 13. Does everybody agree? Because if I factor out a 4 here, that's going to be 9 plus 4. Now, again, I'm trying to help you manipulate numbers better, so it makes more sense. So what's the distance? 2 radical 13. All right, I'm happy with that. All right, so the next page is just kind of a repeat. Uh-oh, look what happened here. Everybody grab this for me as I was typing this up. Sometimes I make a mistake. Paste the image, put 26 over here, get it out of the way, then come up here and just blot this out. Now you're good. Okay. Now look at question 27. We're moving into the next lesson. So here's DE. What's the midpoint of that?
9.
How do you know?
Because it's in between 7 and 11.
Yeah, so D is what? 7 and E is 11. Now, he's correct. The midpoint is 9. Now I want someone to tell me, what if it wasn't easy numbers? How would I get that? How can I find the midpoint?
Middle.
Now I know, how do I find the middle though? So what you're supposed to do now is you're supposed to say, okay, if I look at 7 and I look at 11, how can I make 9 from 7 and 11? It's just a simple formula. If something's in the middle,
You add them up and divide them by 2.
yay, I knew you could do it. I don't want to tell you guys, that was easy. A plus B divided by 2 is equal to the what? That's the midpoint formula. All right. So that's the midpoint if you're on a what? If you're on a line. But of course, we don't really have to know that. We're just smart enough to figure that out. All right. But there is a formula. All right. So the midpoint is just the average, all right, of the 2 points. So now what is BC? Somebody tell me. 1. Now remember, it's been a long time, 3rd year. If you don't know something, I can't help you if you don't put your hand up and say, hey, I don't know where you're getting those numbers from. Right? You got to speak up. All right, here we go. What about BD? Somebody else. What? Say it again. 3. Everybody agree with that? -1 and 7. All right, what about AD, just to make sure? Yeah, you're allowed to have fractions. I prefer what? 3/2. If you put 1.5, it's the same, obviously. All right, so now 31. So what do you think the midpoint is given 2 points that are on the X and Y axis? What's the formula, do you think? Come on, someone be brave. We're not doing the distance.
X plus Y divided by 2.
That's close. But you would never, if you're trying to find the midpoint Tell them, James.
X1 plus X2.
Yay, there you go.
Y2 plus Y1.
Yes, exactly. All right, so the midpoint formula is just the average of the x's and the average of the y's. It's the same thing as if it's on a line, you're just doing two different points, the x and the y. All right, so the midpoint for number 31 is going to be what? 4, comma, 2. Anybody have any issues? 4, comma, 2. All right, what about 32?
0.5.
1/2, comma, what? 0. Everybody good with that? Anybody have any issues? All right, so now P is the midpoint. All right, now this is the one that's usually on the standardized tests. All right, so let's look at this real quick. So here is N, here is P, and I'm trying to find Q, the missing endpoint. So if I say N is 2, 0, and I say P is 5, 2, I'm always amazed at how many people can't tell me what Q is. Q is obviously what? I'm listening.
Like the distance.
No, I just want the coordinates of Q. What are the coordinates of Q? Come on.
7, 2, 8,
Why say it?
8, 4.
Wow, how did you know that?
Because the distance between N to P is 3.
Yes.
2, and then you add 3 and 2.
That's exactly how simple it is. I never understood that. So here we are. We're walking on the x-axis. So if I walk from 2 to 5, I've walked how far? 3. So if I'm in the middle, I'm going to have to walk another what? 3. Now I'm looking at the y values. I start at 0 and I walk to 2. So if I'm in the middle, I'm going to end up at 4. Everybody good with that? So 3, 4 is the answer. Really simple. Really, really simple. Everybody good? That's what I
Why
said, 8,
would
4.
why
It's
would
8.
the X be 6?
I'm sorry, it's 8, 4. I said something and I wrote something different. So again, let me just make sure I said that correctly. So from 2 to 5 is 3 units. So I've got to walk another 3 units if I'm going to be in the middle. So I just add 3 to 5, which is 8. And then I added 2 for the y values. So if I add 2 to the y values, that makes it 4. Maren, does that help?
Yeah.
We're going to do it again anyway. So let's look at 34 since I messed that up. So let's look at 34 again. I have 5, comma 4. I have 6, comma 3, and I have this guy over here. So I want you to put down Q, and then I want you to tell me what Q is. Come on, guys. Come on, guys. Say it loud and proud. 7, comma 2. 7, comma 2. Everybody good?
How do you get the 2?
Because we went from 4 to 3. Right? So I went
Yeah.
back 1. So you subtract 1. Good with that?
Okay. Yeah.
All right. I don't care. 35 is easy. Oh, I'm listening.
-5, 1.
Because we went what? We went from 5 to 6, which is plus 1. You agree now? You sure? So if think about it like this, you're here, you're walking up this mountain. You walk halfway up the mountain. So how far did you walk? 1. So if I'm in the middle, that means I've got to walk another what? Walk another 1. 6 plus 1. right?
Okay.
You remember, Abigail, you're allowed to say, I'm still not seeing it. Because I feel like you're not seeing it. From 5 to 6 is 1 unit. From 6 to 7 is 1 unit. If I'm right in the middle.
We're just adding it to the midpoint.
Yes, of course. Because why? Because you're walking that many. Just like now, watch. I walked -1. So I walk another what? -1. That's how I got 2. You good? All right, I think that's the easiest way to do it. All right, let's just do one more, just because a couple people. All right, let's do it. 3, 9 and -1, 5. All right, come on, people, tell me the answer. What's Q? -5, 1. Is that right? Because I went from 3 to -1, which is what? -4, right? So I just go another -4. From 9 to 5, I went also what? -4. All right, hopefully that's better now. Okay. All right, I gave you a couple cool problems here. I want everybody to try. All right, I want you to see if you can do those. All right, but that's your homework, guys, okay? All right. I'm not even used to the new schedule yet, so what I'm gonna do is I'm gonna find out what time we quit today. Or we're done. St. John's schedule. Today is Thursday, right? So we get out at 34. So that means you got 7 minutes to finish up. All right, 7 minutes to finish up. You guys kind of talk to each other. I do want to say one thing, guys. I know how stuffy and how hot and how annoying it is, but they're asking you guys to wear your masks. All right, it's so hard for me to look up and correct that because I don't care, but you guys got to have your masks on. All right, if somebody walks in and sees you guys without a mask on, they're just gonna yell at me. All right, so I don't want that to happen. So I know you take a break because you want a breath. All right, I understand that. All right, but they want you to wear your mask, so please keep that up. All right. What I'm going to do now is I'm going to stop and we're going to end. And then it's going to be like last year. Oh, bye, Marin.
Hi,
Have a good rest of your day, okay?
you too. Thank you.
And listen, I'm gonna, if I forget, I know you'll remind me, but I'm gonna try to send you your information for your book. I'm gonna try to look it up right now, and then I'm gonna post it, okay?
Okay, I think I got into it, but
Oh, did you? Because I don't want to waste my time. So if you got in, I'm not gonna look it up.
yeah, I think I'm in, so
All
you're
right,
good.
it's the geometry book. Okay, let me know if you're having trouble. So,
Okay, thank you.
all right, take care, kiddo.